Hey guys, what's up? No, not that. This video is about addition and condensation polymerization. Explained to you by an idiot. Explained to you by a confused chemistry student, aka me. Before we jump into the main topic, there's a few things you should know. A polymer is a large molecule made by linking together many smaller ones, and those smaller ones are called monomers. And this whole entire process is called polymerization. So, additional polymerization is when the monomers contain double bonds and the empirical formula of the polymer is the same as the monomer, meaning there is no loss of molecules as the monomers are just being added together. Using an example of ethene here as the monomer, this is how the process works. If we have multiple of these monomers and we want to combine them into a polymer, first the double bonds all open up so they can form bonds with each other. Then they become one giant molecule. This giant molecule is a polymer. Now that was only 3 monomers, but how do we draw it if there are a gajillion of them? We can simplify the drawing by drawing a single monomer on the left, a single repeating unit of the polymer on the right, with the ends representing how many monomers or repeat units there are. This is the process of addition polymerization, even if there is slight differences to your monomer. For example, this propene here can be simplified to this, then made into a polymer like this, and then you put the catalyst in the middle. Same goes with chloroethene, where there is a Cl. This, by the way, forms polychloroethene, or polyvinyl chloride, also known as PVC. Some additional structures and uses for some additional polymers include these. Aha, did you see what I did there? Next up is condensation polymerization. This is when the monomers contain 2 functional groups, and the empirical formula of the polymer is not the same as the monomer, as the monomer reacts with the elimination of small molecules such as H2O or HCl to form the polymer. In condensation polymerization, there are 2 types. The first type is when the monomer contains 2 different functional groups, for example, a hydroxy acid becoming this polyester, which got its name from this ester link, or an amino acid becoming this polyamide, that got its name from this amide link. The second type is when there are 2 different monomers, one of them containing 2 carboxylic acid or 2 acyl chloride groups, the other containing 2 alcohol groups or 2 amine groups. For example, a diol and a carboxylic acid becoming this polyester, and a diamine and a dicyl chloride becoming this polyamide. So, how do we differentiate the 2? No, not like that. So in a type 1 polymer, the ester or amide link has the carbon and the single bonded oxygen or the NH going in one direction. While in a type 2 polymer, the ester or amide link has the carbon and the single bonded oxygen or the NH going in 2 directions. And that's all. If you made it to the video, congratulations, here's some chocolates. May your A-level grades have as many A's as the screams of my pain. Thank you, goodbye.